Article 392, Electrical Cable Trays, mandates that cable trays are securely supported and attached. However, Article 110.20 necessitates that all electrical equipment and installations be safe from physical damage and not cause injury to personnel. Consequently, the height of cable trays must be carefully considered to comply with this overarching safety requirement. There are general guidelines for the height of cable trays that serve as a good starting point. Firstly, let's consider indoor installations. Indoors, cable trays should ideally be installed at a minimum height of 6 feet 6 inches, which translates to 6.5 feet above the floor or any other working surface. This specified height is intended to provide adequate clearance, ensuring that personnel can comfortably pass underneath the cable trays without the risk of being struck or injured. Secondly, let's explore outdoor installations. Outdoors, cable trays generally need a higher clearance. A recommended minimum height for outdoor cable tray installations is 10 feet above the ground or any other working surface. This increased height is crucial to allow vehicles and equipment to pass underneath the trays safely, preventing any potential damage. These height recommendations are not absolute rules but rather general guidelines. The actual, optimal height of cable trays can vary depending on the specific circumstances and conditions of the installation environment. For instance, in areas with high pedestrian or vehicular traffic, or where there is a significant risk of damage from moving vehicles or equipment, it might be necessary to install cable trays at a greater height than the standard recommendations. The qualified electrical contractor responsible for the installation ultimately makes the final decision regarding the placement and height of cable trays. This decision-making process should prioritize the safety of personnel working in the area and the potential for any damage to the cable trays themselves. Factors that play into this decision include the type of equipment operating in the vicinity, the frequency of traffic, and the presence of any environmental hazards. Consider the practical implications of different cable tray heights. If cable trays are installed too low indoors, they could pose a significant tripping hazard for workers and obstruct the movement of equipment. This can lead to accidents, injuries, and potential damage to the cable trays and the cables they support. If cable trays are installed too low outdoors, they could be struck by vehicles, leading to damage to the trays, the cables, and potentially causing electrical hazards. On the other hand, installing cable trays too high can make maintenance and repairs more difficult. Workers may need to use ladders or scaffolding to reach the trays, increasing the risk of falls and injuries. Therefore, it is essential to strike a balance between safety, accessibility, and practicality when determining the optimal height for cable tray installations. Consider the types of cables that will be run in the cable trays. Heavy or bulky cables may require more support and clearance than lighter cables. It is also essential to ensure that the cable trays are properly sized to accommodate the number and size of cables that will be installed. Consider the environmental conditions in which the cable trays will be installed. In areas with high humidity or corrosive substances, it may be necessary to use cable trays made of corrosion-resistant materials. It is also essential to ensure that the cable trays are properly grounded to prevent electrical hazards. Consider the potential for future expansion or modification of the electrical system. It may be necessary to install cable trays with extra capacity to accommodate future needs. It is also essential to ensure that the cable trays are easily accessible for future maintenance and repairs. When planning cable tray installations, adhere to the following steps. Firstly, perform a thorough site assessment to identify potential hazards and determine the optimal location and height for the cable trays. Secondly, select cable trays that are appropriate for the type of cables to be installed and the environmental conditions. Thirdly, install the cable trays in accordance with the manufacturer's instructions and all applicable electrical codes and standards. Fourthly, ensure that the cable trays are properly supported, grounded, and protected from physical damage. Fifthly, conduct regular inspections and maintenance to ensure that the cable trays are in good condition and operating safely. Cable trays are available in a variety of materials, including steel, aluminum, and fiberglass. Steel cable trays are the most common type and are suitable for a wide range of applications. Aluminum cable trays are lighter than steel and are often used in corrosive environments. Fiberglass cable trays are non-conductive and are often used in areas where electrical hazards are a concern. Cable trays are also available in a variety of styles, including ladder, trough, and solid bottom. Ladder cable trays are the most common type and are suitable for most applications. Trough cable trays provide more support for cables and are often used for heavy or bulky cables. Solid bottom cable trays provide the most support and protection for cables and are often used in areas where there is a risk of physical damage. The National Electrical Code, or NEC, provides detailed requirements for the installation of electrical systems, including cable trays. It is important to be familiar with these requirements to ensure that cable tray installations are safe and compliant. The NEC covers various aspects of cable tray installations, including support requirements, grounding requirements, and spacing requirements. It also provides guidance in the selection of cable trays and the installation of cables within the trays. In addition to the NEC, there may be other applicable codes and standards that need to be considered when planning cable tray installations. These may include local building codes, industry standards, and manufacturer's specifications. It is important to consult with qualified professionals to ensure that all applicable codes and standards are met. It is important to emphasize the importance of qualified personnel for cable tray installations. Electrical work, including cable tray installation, should only be performed by qualified electricians who have the necessary training and experience. Improperly installed cable trays can pose serious safety hazards, including electrical shock, fire, and equipment damage. Qualified electricians are familiar with the NEC and other applicable codes and standards. They also have the knowledge and skills to safely and effectively install cable trays. Regular inspections and maintenance are also crucial for cable tray systems. Cable trays should be inspected regularly to ensure that they are in good condition and operating safely. Inspections should include checking for signs of damage, corrosion, or loose connections. Any problems should be addressed promptly to prevent potential hazards. Maintenance activities may include tightening loose connections, replacing damaged components, and cleaning the cable trays. Proper maintenance can extend the life of cable tray systems and ensure that they continue to operate safely and effectively. The height of cable trays is not the only factor to consider when ensuring safety and compliance. Other important considerations include the type of cable tray, the type of cables being supported, the environmental conditions, and the potential for physical damage. It is also important to ensure that the cable trays are properly grounded to prevent electrical hazards. Effective grounding is a critical aspect of electrical safety. Grounding provides a path for fault current to flow back to the source, tripping a circuit breaker or fuse and energizing the circuit. This helps to prevent electrical shock and fire hazards. Cable trays should be grounded in accordance with the NEC and other applicable codes and standards. Grounding conductors should be properly sized and connected to the cable trays to ensure effective grounding. Consider the potential for changes in the future. Electrical systems are not static. They may need to be expanded or modified in the future to accommodate new equipment or changing needs. When planning cable tray installations, it is important to consider the potential for future changes. This may involve installing cable trays with extra capacity or providing access points for future modifications. Careful planning can help to ensure that cable tray systems can adapt to changing needs without compromising safety or performance. Continuous learning is essential for staying up to date with the latest electrical codes and standards. The electrical industry is constantly evolving, with new technologies and regulations being introduced on a regular basis. Electrical professionals need to stay informed about these changes to ensure that they are providing safe and compliant services. This may involve attending training courses, reading industry publications, and participating in professional organizations. By staying up to date with the latest information, electrical professionals can ensure that they are providing the best possible service to their clients. Remember the importance of documentation. Proper documentation is essential for maintaining and troubleshooting electrical systems. Cable tray installation should be documented with detailed drawings and specifications. This documentation should include information about the type of cable trays, the type of cables being supported, the grounding system, and any other relevant information. Proper documentation can help to ensure that electrical systems can be easily maintained and repaired. The selection of cable trays should also be based on the specific application and the environmental conditions. For example, in corrosive environments, it is important to use cable trays that are made of corrosion-resistant materials. In areas where there is a risk of physical damage, it is important to use cable trays that are strong and durable. It is also important to consider the weight and size of the cables that will be supported by the cable trays. The cable tray should be able to support the weight of the cables without sagging or collapsing. It is important to follow the manufacturer's instructions when installing cable trays. The manufacturer's instructions provide detailed information about the proper installation procedures and the recommended hardware. Following the manufacturer's instructions can help to ensure that the cable trays are installed safely and correctly. Proper spacing between cable trays is also important. The NEC provides specific requirements for the spacing between cable trays. These requirements are designed to prevent overheating and to allow for proper ventilation. It is important to follow the NEC requirements for spacing between cable trays to ensure that the electrical system is safe and efficient. The use of cable ties and other accessories can help to organize and support cables within cable trays. Cable ties can be used to bundle cables together and to prevent them from sagging or tangling. Other accessories, such as cable clamps and cable supports, can be used to provide additional support for cables. It is important to use high-quality cable ties and accessories that are designed for use in electrical applications. When making connections to cable trays, it is important to use the correct hardware and tools. Improperly made connections can lead to loose connections, overheating, and electrical hazards. It is important to use the correct hardware and tools to ensure that connections are made securely and safely. The use of labels and tags can help to identify cables within cable trays. Labels and tags can be used to identify the circuit number, the voltage, and other important information. This can help to make it easier to troubleshoot and maintain the electrical system. It is important to use durable labels and tags that are designed for use in electrical applications. The installation of cable trays should be coordinated with other trades. Cable trays should be installed in a way that does not interfere with other systems, such as HVAC, plumbing, and fire protection. It is important to coordinate with other trades to ensure that the cable tray installation is done safely and efficiently. The use of cable tray fill calculations can help to ensure that the cable trays are not overloaded. Cable tray fill calculations are used to determine the maximum number of cables that can be installed in a cable tray. Overloading cable trays can lead to overheating and electrical hazards. It is important to use cable tray fill calculations to ensure that the cable trays are not overloaded. Consider the impact of cable tray installations on the aesthetics of the building. Cable trays can be unsightly if they are not installed properly. It is important to consider the aesthetics of the building when planning cable tray installations. This may involve using cable trays that are painted to match the surroundings or concealing the cable trays behind architectural features. Regular inspections of cable tray installations are important to identify potential problems. Inspections should include checking for signs of damage, corrosion, loose connections, and overloading. Any problems should be addressed promptly to prevent potential hazards. It is important to keep accurate records of cable tray inspections. These records should include the date of the inspection, the findings of the inspection, and any corrective actions taken. Accurate records can help to track the condition of cable tray installations and to identify potential problems before they become serious.